Good morning, good afternoon, and good evening, everyone, wherever in the world you may be joining us from today. My name is Francesco Del Carpio, and I am the CFAL York Operations Coordinator. I would like to officially open the 18th session of our VR XR Training and Education Knowledge and Experience Sharing Speaker Series, presented in collaboration with the DexArt Lab at York University. I will begin today with a land acknowledgement. We acknowledge and recognize that many Indigenous nations have long-standing relationships with the territory upon which our campuses are located that precede the establishment of York University. The area is known as Takaranto and has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat. It is now home to many First Nation, Inuit, and Métis communities. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. The territory is subject to the Dish with One Spoon Wampum Belt Covenant, an agreement to peaceably share and care for the Great Lakes region. As this is an online event and our participants may be joining from various locations, I strongly encourage you to learn about the traditional land upon which you are located. With this, I welcome our moderator, our speaker, and our participants from around the world. Welcome to our webinar. It is now my great pleasure to introduce our moderator today, Dr. Ali Asghari. Dr. Ali Asghari is an expert in disaster, emergency, and business continuity management. He has been actively involved in research, teaching, and professional activities in these fields since 1993. His research has been published in leading disaster and emergency management journals. He was among the founding faculty members who started the first university program in disaster and emergency management in Canada at Brandon University in 2003, and later on among the founding faculty members who started the disaster and emergency management program at York University. Dr. Asghari served as the IAEM Canada president between 2007 and 2009, and as the board member of IAEM during the same period. Since 2015, Dr. Asghari has been the executive director at York University's Advanced Disaster Emergency and Rapid Response Simulation Lab, or ADRSIM. His research interests include post-disaster recovery and reconstruction, business continuity and risk assessment, disaster and emergency simulations and modeling, applications of AI, VR, AR, and MR, and geomatics in disaster and emergency management, and cost-benefit analysis and decision-making under uncertainty. Dr. Asghari is also the director of CFAL York, Canada's first CFAL center within Unitar CFAL Global Network. Dr. Asghari, thank you very much for moderating today's session. The floor is yours.
Thank you very much, Francesco, for the introduction. And thank you all for joining us. We have another great session on VR in training and education. This time, we have a presentation by Dr. Ahmad Mohammadi, who is well known to us and all of you who have been attending this session. He has been moderating many of these sessions, and today we are moderating his session. And as you know, Dr. Mohammadi is a postdoc fellow in the Department of Civil Engineering at York University, Toronto, Canada, where he received his PhD in transportation engineering in 2022. He's currently the coordinator of the Disaster and Emergency Extended Reality Lab as part of ADRSIM. And his research focuses on intelligent transportation systems, the application of virtual reality in enhancing transportation safety and traffic microsimulation modeling. He has collaborated with Canadian government sectors, including the Ontario Good Road Association, to work on the development and improvement of intelligent transportation systems, such as early warning systems for first responders and wildlife detection systems on roads. He's also the developer of what is called Sumo 2, Unity virtual reality traffic co-simulation tool to improve road safety. And I believe this is exactly what Dr. Mohammadi is going to explain to us today. With that, I'm going to open up the floor for Dr. Mohammadi. But before that, I would like to remind everyone that the chat is open for a casual conversation. But if you have a specific question to the speaker, please put that into Q&A, such that we will monitor this portion of the webinar, and we'll go through the questions after the presentation in turn of questions coming to the Q&A part. Thank you again, all. Looking forward to a great conversation and a nice presentation by Dr. Mohammadi. The floor is yours. Go ahead, please.
Thank you very much, Dr. Ali and Francesco. And hello, everyone. So welcome back to another session. So today I'm gonna talk about a topic which contains basically that I have worked 2 years over this topic so far. So the topic is about developing virtual reality. I'm not sure if you see. Do you see, Dr. Ali Askeri, the presentation, correct?
Not in presentation mode. We can see it, but if you put it on presentation mode, that would be great.
Okay, I see. Yeah. So I think that's
Perfect. Yeah.
okay. Yeah. So okay. Sorry. So yeah. So the title is Developing Virtual Reality Traffic Co-Simulation Tools for Infrastructures and Driver Simulator Training. So before going to the next slides and talk about the topic in detail or deep, I wanna say first about what's the virtual reality, and then what's the traffic simulation, and then how we can use virtual reality and traffic simulations in infrastructures and driver training. So let's talk about the fundamentals of VR a little bit for those who don't have technical background in this regard. So if you played games that I'm sure that most of you have played so far, is when the games are made in the game engines, right? So it's a softwares, and the game engines, the softwares provides simulations or replications of what we have in the real world. So let's say in the real world, we have sunlight, right? We have a sky. In the game engines, also we have light and a skybox, which is comparable. So you have a, you have sunlight and a sky there as well, but that's simulations. Also, in the real world, I can localize every object using X, Y, Z coordinates, right? So if you go to Google Map, you can get those coordinates. Same thing is happening in VR also. Then the interesting point is 1 meter in real world is equal to 1 meter in VR in the game engines, because we use game engines to create VR, same as other games, right? So then an interesting experience that I had first time in VR, I took an apple in my hand inside the virtual reality, and then I compare it. The size, the feeling is the same as if you hold or grab an apple, a real apple in the real world. So the size, feeling in the same size, the same, even the distance from your eye with your hand is the same. So that makes VR very useful for simulations and everything's other than also entertainments, but other than entertainments also. Also, we have in the real world we see using eyes, right? And then if in VR also we have eyes, which is in the game engines cameras. Also, the time is almost the same. So 1 second in the real world is 1 second in the simulations, in the game engines. So let's talk about the objects. So when we talk about the objects, let's say the car, in the real world, we have a car which is made of a body, right? And then a color, a paint color on it, right? So in the game engine, I mean, the ideology is the same. Like it's, again, a game object like car, which has some meshes that we call, and then those are digital lines. And then we put or cover it with the material and textures. again, so these are the fundamentals. I'm just maybe somebody is curious because during the past sessions, I saw many persons that ask about uh, these questions about what is VR even, right? What's the game engine? How we can make a VR game, right? Or how the VR works. So I'm talking about those things. So moving on to the behaviors. So in the real world, we have gravity. So when you, for example, just take an examples of Apple, right? So in the VR, we call it, or game engine, we call it as a rigid body. So the naming is different. The concept is the same. So if you just relieve or leave it, an apple, so it will fall down, right, on the ground. Or the complex behavior, we have water, fire. Again, we can simulate these things in VR as well inside the game engine. We have collisions, we have wheel rotations, right? So all of these are kind of the behaviors which make VR very useful to create and to applicable to many applications. So from the disasters to the simulations of the driving, this driver training, right? And uh, then to teach, for example, chemical courses in to the kids, right, in the schools or high school, right? So then uh, moving on here in this session, I'm gonna talk more about the traffic objects and also how we can be as a persons in as a traffic objects inside the VR. Let's say we can be a driver, we can be a pedestrian, we can be a wheelchair user even, and then experience, right? Scooters, rider, cyclist, or motorcycles, right? So you can do every of these scenarios now in VR. So you don't need to, so the following questions might arise is, okay, why not we are just experiencing these things in the real world? Why we need to do it in VR? Then the answer is in VR, you can change the scenarios and the simulations going from, let's say, from a fire scenario to a earthquake, right? You can replicate these things, but in real world, you cannot. And then with the goal of teaching somebody, right? So let's say about the driving. So right now, there are many companies that they are doing businesses in the training of the drivers. Let's say starting from the left, Virage Simulations is one of the famous company that they are doing business in truck driver training. So as you know, uh, when you want to get a truck driving license in North America, I'm not sure about the other regions, but you need to spend sometimes inside the simulations. So let's say out of 100 hours of training, about 30%, 40% is inside the simulations, and then you will sit inside these driver simulators on the left side, and then there are scenarios that you need to go through it and pass it. So can you imagine that? Like they are already using this type of simulation as a part of giving the driver license in Ontario, right? So same thing you can right now, you might ask, for example, okay, in the left side image, there are displays, monitors. There is no VR headsets, right? But they have it. They can do it using VR as well. But in these images, it's just the displays, the monitors, right? But the idea is the same. Also, there is another company that they are doing business for example, teaching kids or teenagers about how to drive the car, right? Or emergency car driver training is another one because uh, you cannot simulate it in the real world, right? How do you want to put, for example, somebody uh, behind the wheels, right? And then run a emergency car driver training in the real world. It's very tough. So you can do this inside the VR then. So there are a lot of companies that they are doing businesses in other areas, but I'm gonna specifically talk about the training of the drivers. So the thing now, the question is, okay, how can we improve it? So the existing condition is, let's say the companies are using VR to train the trucks, the passenger cars, and other drivers, right? So the thing is, there is a challenging part here, is the developing of those scenarios. So when they want to develop uh, different scenarios, let's say for a truck driver, right? So a truck driver might go to the highway. A truck driver might learn about merging, diverging to the highway, right? Using expressway or in the intersections, how to turn left, right? It's different from the passenger cars, right? So assume a truck with a trailer, right? It's a long vehicle. It's not very small. So those scenarios, it's a little bit difficult to create inside the VR, especially when it wants to have an interactions with the other traffic objects, right? So as you can see in this slide, I put, for example, a snapshot of the game GTA that you might already have played it or heard it, right? And then the traffic system for the games normally just serves the purpose. So it's good for the entertainment, but it's not necessarily scientifically justifiable. So in the real world, let's say people's, when we see an objects or another car, right? We have a stopping sight distance, we have a braking distance, but these are not applied to the games, to the traffic systems, to the games, because they don't need to, right? It's just for the entertainments. So those companies, they are using also relying on the same things that is already created for those games. So it's very tough to difficult to develop those scenarios and then a real world traffic system, right? So now moving on. So far I told you about what's the virtual reality, right? And then what this is the use cases in the driver training, right? And what's the challenges that they are facing now? Now moving on to traffic micro simulations. So micro simulations is the softwares that they are not game engines. They are built for the different purposes. So in the macro simulations, we are simulating railroad, heavy vehicles, passenger cars, pedestrian, bicycles, right? Air transportation even. So what's the goal? What's the purpose? So why? Why we are using the traffic macro simulation, right? So the answer is the engineers, when they are changing the design of an intersection or highway, okay, they cannot simply go to the highway and then change the designs, right? So assume, for example, there is a highway, there is an expressway in your town, right? So if the municipality city wants to add another lane, okay, or another scenario, there is an intersections. City wants to, for example, change the intersection to roundabout, right? So they cannot simply go there and then do it, right? Because they need to do some justifications. If you change it to the roundabout, then what's the impact on the traffic in future, right? And let's say 20 years ago, when you create a highway or expressway right now, then 20 years later, the traffic volume might get increase, right? Exponentially, it will increase, right? Then you cannot simply change because it's a concrete. You already created. You cannot destroy it and then, So that's why they use traffic macro simulations first, create all of those corridor inside this software, and do the traffic analysis there. So they put the traffic volume, these cars will move, for example, and then they change the layout, and then based on some indicators, they can understand, okay, what would be the impact in future, okay? So then that means that traffic simulation is built, first of all, based on some justifications for the drivers to move or pedestrians, right? And second of all, for different scenarios, right? So if I want to talk about the driver behavior and then how we need to replicate these things. So we use car following model and lane changing models to replicate the same psychology, basically background that you apply when you drive, right? So when you drive, if you see, for example, a leading car, then there is a headway between you. You do not, for example, just take a break, right? So it takes time. So there is a side distance. There is a stopping side distance. And then you are calculating everything in your mind, right? So this is not applied in the game engines. Game engines, they do not care about these things because it's for entertainment, right? But in micro simulation, we care. So in North America, at least every almost highways, intersections, if they want to change something there, if they want to design from the scratch, they normally use micro simulations. So now there are two gaps, right? One is in the companies, in the driver training, right? They wanna create complex scenarios. They need to, right? Because they want to train people. And then another one is in transportation planning also. All of those movements of cars is based on the equations, right? So that's a weakness because again, someone might ask, still these equations might not replicate the real world behavior, right? So that's a good question. So then what we came up, we are thinking to take control of one object inside the macro simulations, right? And then put a virtual reality and then observe the peoples, the movements. So those movements are coming from the micro simulations. So it's called the CoSimulations. So basically you are immersing yourself inside the micro simulations, right? So maybe next slides and the next slides will give you more insights. So the methodology that we are taking and moving forward is on the left side, we have traffic micro simulations. On the right side, we have the game engines, right? And then that guy is me, basically, is using deriving inside the micro simulations, right? So there are some steps that I'm gonna just move to show you a video. So this is the final product. So I first show you the final product and then talk about a little bit about the concepts, right? Because it will give you more understanding about what we are doing. So then as you see, I'm taking control of that car inside the macro simulations. And now deriving. In the left side is a macro simulation, right side is the game engine, right? So now we are able to take control of any objects. And those surrounding cars inside the game engine, those are coming from the micro simulation. They respect me as a driver and then applies all of those methodologies, right? So then what's the goal? Why this is useful? Then again, for the traffic, for those companies, it's useful because they don't need to spend much time about the AI things, how those cars should move, right? They need to spend times and then money and efforts and design all of those movements, right? Using AI. And AI, at some point, somebody may ask, okay, what's the justification if the AI works fine or not, right? But here, the micro simulation works fine because we are designing the infrastructures based on the micro simulation now, right? So this is reliable. And then another benefit is for the transportations company and then the cities, because the cities, for the city, letting the community experience things is very important, especially in North America. So when they want to change something, if you live here or in Europe or some countries, so normally if city wants to change something, then they will come and then to the area and then promote peoples to participate, right? To some exercise. They will show some posters about the future designs. They will get some feedbacks before doing anything, right? So this is great for that feedback. So we let peoples go to the future designs, right? And then we can collect now the data, right? Based on this behavior, because people put the VR headsets, they go through these experiences, and then we collect the data. The data is the feedback from, for example, how it looks like, right? And then it's a qualitative, we call it, or quantitative. It's, for example, the trajectories, the delay of the peoples to get, for example, from one intersections to another intersections, right? So these indicators that we normally use in transportations. So again, two use cases, two benefits so far. One is to develop different complex scenarios for car driving companies, right? And another one is to get the feedbacks, quantitative, qualitative, for transportation planning companies that already use the micro simulation. Okay. Okay, so if I want to talk a little bit, I'm not gonna go towards many technicals, as I don't like to, and then also you don't like as well, right? So, but the idea is this. Let's say we are using PTV Vism on the left side as a the traffic simulation, and then on the right side is a Unity game engine. Then we need to grab all of those cars trajectories real time, right? And then it's less than second. And then bring those information to Unity and then take one car as a simulator vehicle, right? And then returns those trajectories to Vism so that when I drive, so you would have that experience that, okay, you are driving and every other objects are respecting to you. Okay. Now you can do this using a car. You can be a pedestrian. You can be a truck driver. You can be a scooter, motorcycle, everything inside the Vism that we are doing. Now you can immerse yourself as that objects, right? Okay. So the most challenging parts is not about the connections of these two, is about the matching these maps, because the road network inside the macro simulation is two-dimensional, and it's in different format. We call it as open drive. And the roads inside the Unity game engines are 3D models, right? FBX, we can say, right? So these are two different formats that needs to be matched. Otherwise, those cars, they don't drive on the road. They will go, for example, out of the border or somewhere, right? So these two should be matched. And then, so for that, let's say the top image is the real world, right? It's a highway 401. And then we use a software called Roadrunner, and then it generates both formats. When you create the roads, it generates both two-dimensional and three-dimensionals. So it's very powerful when you want to create the road infrastructures for your game or your simulation or whatever experiences that you have, right? Uh, this is the process. Let's say we because when I'm talking about this topic, I'm engineer, right? So for me, I'm doing engineering work. So whatever we are creating for the roads, for the interchanges, is based on the real world. It's not just randomly created based on something, right? So on the left side, as you might have some knowledge or not information about the contour map. So that's the elevation map. So we put the elevation map. We consider also the aerial imagery, right? And then creates these interchanges. And then on the right side, you can see these interchanges inside the Unity. Uh, and then in the middle, it's inside the macro simulations. So, sorry, moving on. Okay, when you create this framework, there is another step, which is a VR-based driving simulator, because uh, Unity and everything that I have talked is a software, right? Now we need hardware so that so I can carry the feeling of the driving to the drivers, right? So we need the steering wheel pedals. For example, here we have a low fidelity, they are saying, or low quality type of VR simulator. So let's say we have a VR headset, we are a steering wheel and pedals that you can purchase it from Amazon, right? And then also for the truck, we need a shifter because the trucks usually needs a shifter, but the cars in North America, we don't have shifter, right? So then we can create these driver simulators and let people to drive and experiences, right? Also, another component is when we are doing all of these efforts, then the question is why not developing also a visualization interfaces for uh, city or mayors, because they don't want to go in the details or technicals of the projects, but we can show a general understanding of the designs, the changes, the results of the projects, right? So this part is basically mainly is for the planning, transportation planning sites, not for companies, the deriving companies, no, not for them. But I'm gonna show you. So this is the platform that the interface. So that we have created. All of these movements of cars are coming again from the micro simulations, right? But this time, it's a passive way. So we are not deriving inside the macro simulation. We are just recording those coordinates and putting inside the Unity, right? So that we can send an applications to the city or mayors, and they can run it on their computer without needing the vsim or like the macro simulations, right? So then this is a passive. You cannot derive. It's just for immersing. It's just for visualizations and showing, for example, the highways, the movements, what would be the future, for example, traffic volumes, the impacts, right? And all the results and changes in the network. Yeah, so then this is the last slide. There are also a couple of other applications that we would imagine. One is about the data collection that I have already talked. The second one is the visualization I talked. The third one is about testing the computer vision algorithms, because there is a big area, let's say the computer scientists or computer science, they are working is to train the vision algorithm, to train the AI, right? To train the AI, they need pictures, they need images, they need the real world or simulated images to train, right? So then this framework can help, because the thing is, let's say the car driving companies, right? So what they do is install a sensor like Tesla, right? They have camera, and then those camera captures the image, the real world image, right? But that's expensive to do it. And then they cannot capture any mini scenarios, right? Because, for example, what if we have a collision? What if an animal jumps in front of the Tesla, right? So these scenarios, they first created using the simulations, right? And now how we can train the algorithm. So when you put inside the simulation, then you can collect these images, right? These scenarios, and then train the algorithm, right? So then this framework could help. And also similarly, like for connected and autonomous vehicle technology, it's applicable. And another one is about the digital twin. So the digital twin, maybe I can briefly just tell you what the digital twin means. So digital twin, many people might think that the 3D models is digital twin, right? So what I have shown you is digital twin, but it's not. Digital twin is a 3D model plus the real world data that comes from sensor. Let's say in the visualization interface that I have already shown you, it's if we can get the weather data real time, right? And then somehow show this is the digital twin, right? Or if we can get the real world traffic data real time and then show, right? This is a digital twin. So now the thing is the idea about how we can use this methodology is, let's say right now, all I showed you and all the transportation planning is doing is based on the collecting passive data, right? So we collect the traffic data for 1 month, and then we do all this analysis, right? But what if we can collect the traffic real time and then change these scenarios, right? In real time. Let's say this is applicable for dynamic variable message signs. So if you, for example, if you have seen on the roads in Ontario, we have a couple of space that it shows the dynamic variable message signs on the road, right? But those are more about showing information about the weather or, check your tire in the winter. But what if we can use those variable message signs to show information about the traffic, right? So then, or about the 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 best lane that they can take, right? So in this way, we can get the data, live data, and then fit the framework. It provides you the delay, for example, the travel time, right? Using the macro simulation, and then you can show this information real time. So instead of estimating, right? So yeah, so these are other applications that we are think of. But yeah, that's the presentations. I think, yeah, I spent quite enough time and talked about this topic. So yeah, thank you very much for sharing your time. Thank you.
Thank you very much, Dr. Mohammadi. It was very interesting, detail, and quite a lot of work that you have covered in each of these slides. Now I'm going to open it for some questions. I already saw a question from Osman on the chat, but I'm going to read it for you. And then I will open up the microphone for Sajjad to ask question. Now, Osman asked, of course, thanks your presentation. And the question is programming required to transfer vSIM simulation to Unity as shown in the presentation? Please elaborate more how to do on Unity, if you can. That is a question from Usman.
Okay, yes. So Yeah, so basically you need the macro simulations and Unity on the same computer. And then it's a programming. So you need to collect those data from the simulations, fit to the Unity, and then return the data from Unity and feed to the micro simulations, right? So um, we we felt that people might have many questions about this when we are sharing these experiences. Then we created an open source project which works based on the macro simulation, Sumo, and Unity. So then maybe I can share uh, the link
GitHub link.
because
Yes, that would be good.
yeah, and then it has all the components. It's in the GitHub. You can clone or just simply download the projects. And then we have also a couple of videos that showing you how to go step by step and then run that exercises. So maybe I can share with you the projects so that you can go through it step by step because I think it's easier if you want to learn about the technical matters because it's very technical, these questions, by the way.
Okay. Thank you very much. I'm going to open up. I'll get back to you, Osman, after I open up the microphone for Sajjad. If he is still here, I don't.
Yes, I can.
You are? Okay, so you are already open. Go ahead, please ask your question.
Thanks, Professor Ali Asghari, for arranging this session, and thanks, Dr. Ahmad Mohammadi, for the insightful discussion on this topic. My actually research is also pretty much similar to this domain, and I was just, first of all, this insightful contribution on the open source GitHub, that is very essential for all these researchers. So as far as we were talking about the digital twin, um, given the limitations from different micro simulation softwares, we always face a sort of because digital twin needs the real data set to represent the actual behavior of pedestrian, or maybe bicyclists in some case, or in your case vehicles. So my question is, like, what if we add, because single research group cannot obtain all sorts of data set, or they cannot merge all sort of applications together. For example, one computer science background group can contribute in terms of visualization, or traffic engineering group can get the and acquire the drone data set from some highway, or maybe some mechanical or industrial group can obtain the vehicle vision data set, by having a few cameras inside and outside vehicles. So what are your thoughts on it? For example, if we integrate the data from different sources, let's say we have German highway drone data set where we have source of micro simulation features, and we have few information from another source which has the video data information, and we have the, for example, let's say your group has the capability to merge and integrate all those different source of data set and use for this purpose. Do you think this would work? Although I understand that one environment has few characteristics, and that cannot be acquired from integrating from different environment, but still different micro simulation algorithms, they do have such limitations as well. For example, if we are using the Vism micro simulator algorithm, most of the researchers, they don't rely on that because they feel that cannot represent the actual behavior. So what are your thoughts in this regard?
Okay, thank you very much, Dr. Sajjad. Okay, so I think I can divide your questions to two sub-questions. So first one is about the digital twin. Is when we are talking about the digital twin, then you are saying, okay, we are getting, for example, different data from different sources. Then we want to use them to show on top of the 3D models or do some sort of analysis based on those data and then showing, right? So then if that's the question, then what I can say is this framework is basically does not involve with the microsimulation because you can get the data and you have the Unity part, the 3D models, right? You can just connect those data to the Unity. So when you wanna involve the microsimulation in this regards, then you need to at somehow get those data and then fit to the microsimulations. And then at the same time, visualize in the Unity because that's a digital twin, right? And then get some feedback from the microsimulation, right? So people are doing this very few people right now are doing this, but this is very complex, and I put as an applications, but it's possible. So then the second question is, uh, many people do not use the macro simulations still, and because it's not perfectly matched with the real world, right? And then that's the challenging part. Then I told already that, yeah, people arguing that it's not reflecting the real world behavior, right? So now we are saying, okay, why not now I can take control of one object there, and then that's a real world behavior of now me, right? So then we are uh, at somehow relax that problem in such a way that I am the driver. Now I am putting myself inside the micro simulation. Now get the data of me, right? And then do the analysis. So in this way, you relax that problem in such a way that you are going around, right? Because you are now using real, almost near to real world behavior data because I am the driver, right? So I hope that answers your question.
Yeah, sure. So thanks, Dr. Ahmed. Actually, yeah, it has so many complexities involved, and but for sure, this is a field which is emerging, and we can have, different solutions to solve this same problem. Thanks for your insights.
Thank you very much, Dr.
All right,
Sajjad.
we have some more questions, so we need to be cautious about the time. I'm going to read for you some of these questions. There are multiple questions from Joseph. I am going to read them one by one, and hopefully we can go through them within the time. And also have another question from Argaban and perhaps also Masood. So let's start with a question from Joseph. Of course, he thanks you for the presentation and asking first question. When you mention microsimulation, what a specific type of modeling and simulation were you referring to? Was it discrete event simulation?
Okay, so it depends. I mean, when I am saying the simulation, it can be any logic, which is a discrete. It can be continuous, like VISIM, right? For example, we connected so far two simulations. One is VISIM, which is continuous, and then one is SUMO that I have already shared. It's a discrete, right? But as long as the simulation can provide the trajectory data and then we can get it, then we can do this exercise inside any simulations.
Thank you. I think this is clear. Thank you. The next question from Joseph is, in the context of creating VR simulations for training, is it necessary to validate your models against real-world data, or is it sufficient to base them on the specific scenario being simulated?
Okay, so then if Joseph is asking about validating uh, the the framework, basically the questions then goes back to validating the traffic simulations because we with or without VR or Unity, we are validating, verifying those results from the macro simulation already, right? So that's one step. Then when we are doing this exercise, the experiments, so let's say we invited usually 40, 50 people, 50 people to go through this experiment, right? Inside the macro simulation. Then there is a second validation or verification step, right? Similar to questionnaire. When you, for example, do a survey, you have a validation or verification, right? It's similar. So this experiment is just a 3D survey. You are letting people to do the exercise, right? Survey is just asking the questions, verification afterward. Here, you are letting people to go through this experience. Afterward, there is a verification, of course, and those methodologies applied as well. So there are two verifications then.
All right, thank you so much. The next question from Joseph is regarding the connection or interoperability between VR simulation and, of course, the simulation tool you are using. So the question is, what standards did you use for interoperability and integration between VR and simulation? For example, did you utilize HLA? HLA is mainly used, for example, for communication between. It's used. We use it before between any logic and Unity. Is something or a standard like this you are using? Basically, I think the question is how real-time connections between the micro simulation and VR is working in terms of a standard or approach that is used there. I think you basically the GitHub codes that
Yeah.
you are sending is taking care of that, but you want to explain that further, please?
Yeah, so so the difference is I'm not sure about the other simulation softwares like any logic, but traffic macro simulation, just forget about this framework. Before that, we usually take control of, for example, one traffic light and then change it, right? Because we want to put, for example, signal priority. So there are some API that the software provides already to take control of one objects. So then what we need to do is just figuring out that API and then do this connection, right? Because there are two stages. The first stage is just getting the data from Vissim and then feeding to the Unity, right? That's just the trajectory data. It already provides in many transportation software because we are relying on those things to do the analysis, right? So same thing we are getting and then mapping to the Unity. But the real-time connection, basically the core idea is getting that control of one car inside the Vissim and then moving that, right? So that's the idea. And that's through the API. So they already provide. So we didn't use any external platform. So the languages is Python and also C#. You can do both.
Thank you very much. I think with that, you also answered the last question from Joseph. I'm going to use the remaining 5 minutes to read for you a question from Argaman first, which is, of course, thanks you for the presentation. And the question is how we can implement the real world in a detailed simulation program, such as the details of maze of the past. I didn't get the essentially the question, but I'm guessing that you can read the question also if you can figure it out what it means.
Yeah, so maybe I'm not fully understand, but I can answer these questions in a way that so let's say in the real world, what we do as a transportation planner is we use an imagery, Google imagery, right? Map of, for example, an intersection. And then there is an elevations, which has the information of height, right? And then these two source, we use it inside the 3D softwares inside, for example, this like civil 3D, right? For civil engineering, right? And then start drawing the roads based on the real world. So that part is already there. And then what we need to do additionally is to get one export for micro simulation and one export for the Unity so that we can run the real world examples that you are seeing, right, on site in micro simulation and also derive inside the Unity. I hope that answered the questions. I'm not sure.
Thank you very much. There are two more questions left here. The first is from Masood. That is, some of these questions are relevant to previous ones, so feel free to, summarize that. I find your research very interesting. However, I'm curious to know what challenges you face when implementing your work on large scale problems.
Yeah, so when it is very large, I mean, the traffic macro simulation is designed for a large scales. So what we do normally is we do not send the informations because we are talking about one car, right? One car there, and then there is like a circle boundary that out of this circle boundary, whatever car is there, they don't impact on you as a driver because you have a sight distance. So we don't send those data out of this boundary, let's say 500. So whatever your network is bigger or larger scale, that doesn't much impact on this connection because that's related to micro simulation, not this connection. Because if micro simulation can handle it, then the connection can also handle it.
But do you need to create the larger scale in Unity also?
It depends on the experiment. Let's say if we are doing the experiment on just one simple intersections, right? And then we wanna run this experiment, then you don't need to create all the things inside Unity. You need to create it inside the Vism simulation because it should replicate the real world. But for that, because the driver cannot see other highways, right? And then we do
Yes.
not send those data. But this driver data impacts on whatever the vehicles are doing in micro simulation.
Okay. Thank you. Just one more last question in
Yeah.
1 minute that we have.
Yeah.
It is from Osman. Is it possible to make a micro simulation on Vissim and convert on Unity or send it to Unity for mock testing for user?
Okay, so this is the answer. Short answer is no right now, but we are working on it to see because this is at the end needs to be done using AI if you want to do it because the problem is the road network. It's not about the scenario. It's just the road network because road networks needs to be same, right? Every other things, let's say traffic lights or moving the objects, we are getting the data, right? And then mapping inside the Unity. The only thing which is very important here is the road network. So then now, right now, there is no any platform to make a 2D network to the 3D network, right? So it's tough, this one. Yeah, this exercise is very tough. Yeah.
Okay, thank you very much. I see some other comments, but all together, I think everybody enjoyed your presentation, and we very much appreciate your time and efforts, and looking forward to more of this kind of presentation from you and the team. And also want to thank everybody who has stayed with us throughout this session. And I'm sure there will be another session, the last session of this speaker series on in November with, I don't know if we have detail that we can show. Francesco, yes, I'll give the floor to you to introduce the last session. And from me, that's all. Thank you, everyone.
Yeah, thank
Thank
you
you.
very much, Dr. Ali. Thank you. Francesco.
Yeah, yeah, thank you very much, Dr. Sgary. Thank you as well, Dr. Mohammadi, for that great presentation. And I'd also like to echo my thanks to everyone in the audience for joining us today, participating, and staying a little past the final or the official end time. As for the last session, as Professor Asgari mentioned, it will be on November 19th. The speaker is Vicky Devils from IMVR. We do not have the final topic yet, but please join us as it will be our last session. Um, and we are looking forward to her presentation. Yeah, so please, if it's of interest to you, please mark that down on your calendar and hopefully we'll see you then. And please feel free to share the link to the series or the videos, recordings of all of the sessions on our YouTube channel. Please feel free to share those in your network as well and encourage anyone who is interested in VR to sign up for the last session if they haven't already. Registration is open and free, and it will be open until the start of the last session. So again, that's just November 19th at 12 p.m. Eastern Time. Yeah, and with that, just one last big thank you to everybody. Thank you so much. Take care and have a great day.
Thank you very much.